Right, let's crack on with this light worksheet. Heavy on the brain, light on paper. Right, let me just quickly go over this. Yeah. So this is air, and this is low density, and this is glass, and this is high density. So now there's a ray coming in. This is called the incident ray. You've got your normal. That's supposed to be straight line. That's supposed to be perpendicular, right? So that's the normal. Right, now because you're going from low to high, this angle here is your angle of incidence. Right, instead of it going straight that way, what's going to happen? It's going to bend towards the normal. So I've exaggerated it there. So this angle here is the angle of refraction. Angle of refraction. You've got to start learning these, otherwise it's just like just a soup or just a mess in your head. Right, so remember when you go from low to high, it bends the ray of light bends towards the normal. Right, so let's draw the normal here. So what I'm going to do is I'm going to try to draw it as a straight line. Yeah. This is the angle of incidence, and this here is the angle of refraction. So it comes in at, just say, at certain speed, let's just call it x, and then because it goes from low to high, it goes to speed y, and it slows down. So it slows down, the speed of the ray slows down, and then that's where you get a change of speed. The ray changes direction. So we can say it's high speed and we can say low speed, just for now. Right, okay. So we need to describe what happens to the light ray when it enters prism at point A. So let's write this down here. Right, first thing, the light changes direction. The light refracts, or just, you can put, instead of refracts, that's probably a better word, just say changes direction. Right, it changes speed as well, but that's part of that. And the light refracts or bends towards the normal. Okay, state the name of line XY. So this line here, can you see it's at 90 degrees to the boundary? So it's called the normal. It's called the normal. State the formula linking the critical angle and the refractive index. Right. Sine of the critical angle is 1 over refractive index. And what is the, so n is called the refractive index. You'll get this anyway. So n is simply sine is it sine I over sine R, infrared. Yeah, that's how I remember it. Infrared. So the angle of incidence over the angle of refraction. So it's the angle of incidence. Did I call that R? I believe I did that. So it's going to be less than R, I. So this is R and this is I. Incidence, refraction. Right. Now they've given you the critical angle. No, so they want you to work out the critical angle. They've given you the refractive index. So basically you've got this formula. So what you do, and don't skip any steps. So they're saying sine C equals 1 over 1.6. C equals sine to the minus 1 inverse sine over 1.6. You can work that out. You can work this bit out, and the way they've shown it in the mark scheme is 0.625 equals 39 degrees. Okay. Right, so we know the critical angle is 39 degrees. This is the key now. So this is where they're going to differentiate your grade. They're going to say, yep, this person understands what's going on. Right, how do we do that? Nope, that was a bit slow, but right, delete that. Right, okay, at point B. So right, don't be fooled by this. We know this angle is 60. And the critical angle we've worked out is 39 degrees. So the angle of incidence is bigger than the critical angle. So we're going to get total internal reflection. So it's going to go that way. So this is what you need to do. Right. Complete the diagram. Yeah, that's it. So you've just got to show that because your angle of incidence is greater than the angle, the critical angle. Done. Right. Oh, part B. Diagram 2 shows a similar prism that is made from material with different refractive index. So this might be clear plastic, transparent plastic. The critical angle is 55 degrees. So we know that there is 50 degrees because that's a right angle. That line there is the normal. Right, so when the ray comes in, it's gonna go from high density, and air is the lower density, so it's gonna bend, it's gonna refract or bend towards the normal. No, I'm doing that again. See, I always do that. Ah. Right. That's if it goes straight through, but we want it but it's going from high to low, not low. I always get this wrong, low to high. If it's low to high, it bends towards. If it's high to low, it bends away. So be careful with that. I always make that mistake. And don't make that mistake. So there you go. So that is greater than 50 degrees. So that might be, I don't know, 58 degrees or something. It doesn't matter. As long as it's more, they've done the normal for you, that's fine. So it's refracting away from the normal. So don't make my mistake. This is the, I think, second or third time I've done it. Right, let's move on. What is that? 10 minutes. Okay. Let's keep going. Right. This question is about wave behavior. The boxes give 3 types of wave behavior, and the diagrams give 3 examples of wave behavior. Draw one straight line from each wave behavior to the example that shows. Right. So this, you can see, is just totally reflected. That is straightforward reflection. That's not a problem. Right. This is total internal reflection, because it's inside the glass block. So you've got that there is total internal reflection. Now, remember I got this wrong on the last one, so let's try to get it right now. So we're going from low to high, so it's going to bend towards, a normal. Right. So we're going from low to high. That is the angle of incidence. This is the angle of refraction. So this is where you get refraction. What else is it? Oh, okay. I thought there was another one, but maybe not. So this is refraction. So this is the ray of incident ray. This is the refracted ray. This is the angle of incidence. This is the angle of refraction. Right, 2 common properties. Can you remember what we said? They travel at the same speed. They travel at the same speed. They reflect, refract, they transfer energy without transferring matter. They have the same frequency. No, not speed. Because it does change speed when it goes through here. So I'll take that back. So the first one, all waves reflect, they refract, they all waves transfer energy. Yeah, you can leave it like that, without transferring matter. You can put that in, but they all transfer energy. They all reflect, refract, and all waves have an amplitude or wavelength or frequency. Okay. So the 2 most obvious ones, they all reflect, refract. They all transfer energy without transferring matter. Right, let's move on. What was that? Okay. Right, okay, we'll call it quiz at that.